Okay. This is the 24 that we worked on yesterday. You all agree? Which Lerato requested us to work on. And then we agreed. Here. Remember, my request yesterday was that you will go and rework this number 4, and then you will give me the final answer that you got after reworking number 24. After you, it will be Abdul, followed by Theo. Then after that, we'll go to Nomtandazo. Lerato will be the last. Thanks.
Okay, my answer hasn't changed. It's still k cubed minus 8k squared minus 10k plus 95.
Are you sticking to what you got yesterday?
Yes, sir.
Is it what you found after reworking it?
Yes.
Okay. Mr. A. Matsuso. Abdul.
Sir.
How are you, my brother?
I'm good, thanks, and yourself?
Good. Have you got a different answer from yesterday or what?
I'm standing strong on the answer of k cubed minus 8k squared minus 10k plus 95.
Okay. Thank you, Abdul. Theo.
Yes, sir.
Are there any changes from the answer that you shared with us yesterday?
I am happy to report that my conviction is as bolstered as it was yesterday. And so, no changes whatsoever.
Okay, thank you. Nomtandas.
Yes, sir.
Yesterday, your answer that you shared with us was k cubed minus 8k squared minus 2k minus 107. Are you sticking by this answer or has it changed?
It has changed, you say.
To what?
K cubed minus 8k squared minus 10k plus 95.
Are you sure?
Welcome to the family.
Yes.
Oh, wow.
Welcome.
Nomtandazo,
Yes,
what Kia, Abdul and Theo found? I'm not convinced with it.
I am, sir. I'm confused with it.
Even though you are being welcomed to that family, I'm not convinced with their answer.
At the end, you will say.
Or are you
Don't
that?
try to confuse. Don't try to confuse Nomtandazo. She's seen the light.
All right. Lerato.
It's the same.
My brother. Yeah?
It's the same.
No. Yesterday, you gave me this answer.
Same as today.
Sorry?
Same as Nomtandazo's answer.
Oh.
Because like yesterday, I was not doing AD minus BC. I was doing BC minus AD.
Oh.
So, yeah.
That explains a lot.
Hey.
You're also welcome, Lerato. You're welcome.
Okay. Okay, thank you, Lerato. Let me thank everybody for having double-checked their answers. And then I'm happy that you got the same answer. So, can we now step off this and then go and talk about Cramer's rule?
Yes, please.
Properties of determinants and Cramer's rule. Basic properties of determinants. Okay. I just don't want to bother you with many things or many stories. Okay. Here, maybe what I can just emphasize is to say the determinant of, remember, when we add matrix A plus B, what they are saying here is to say the determinant of the sum of matrix A and B is not equals to the sum of the determinant A plus determinant of B. And then let's look at this theorem. Hello?
If my memory serves me well, so it means the sum of those matrices are not commutative.
What is, yeah, please remind me that word, Mr. Matsuzo.
Meaning,
please.
Is it commutative?
So hence I'm saying, meaning if we're going to have the determinant of A plus B, according to that commutative law that we once discussed, if you have determinant A plus B in brackets, you can break them apart and make it determinant A plus determinant B. So now based on this law that you just showed us, hence I'm saying, looking at the fact that it is not equal, so that law means that it is not commutative.
Mm-hmm. Yes.
Okay, thank you, sir.
Then I don't think, I think it's straight. Is this straightforward?
Yes.
Okay. Then now let's continue if it is straightforward. Now let's look at this lemma. This lemma says, if matrix B is a square matrix and E is a square elementary matrix, then determinant of EB is equals to determinant of E multiplied by the determinant of B. Do you see the difference between this lemma and this theorem?
Yes, yes.
So what is a lemma?
Yes, I was about to ask as well. What is that? I know what a theorem is, but what is a lemma? I've never seen that word in my life.
I think I would be happy if we had to go through maybe an example, because right now with all these A's and B's, it's a bit confusing. So maybe if we had to go through an example, it might be a bit better.
Okay. I'm noting that, Abdul, then we'll go through these examples. No, where did... we did talk about this theorem, no? Kia?
Yes, told us.
Kia?
Hello, sir.
I think I'm not in the right frame of mind. I think I should leave.
Who?
Me.
I'm okay today. Don't worry.
No, me, not you, me.
Oh, I don't know. That I'm not too sure.
Are you not releasing me? Okay. All right. Then let's... Okay. Yes, Abdul, I've noted your request. Ne? Lemma, yo, Lerado. Lerado.
Yes, sir.
I'm unable to tell the difference between a theorem and a lemma. What else can I say? It's a definition. It's a definition. It's a theorem. It's a lemma. What is another one?
Sir, there are
Yes.
theories, lemmas, rules. That are different things.
Yes. I'm happy that you do notice that they are different things.
Yes, but then the lemma one, for example,
What is a lemma? What to say? What is a lemma?
and it's then it's something that has been said before. I don't know.
What lemma?
I know. I posted it in the group. Now we know what it is.
A lemma. Definition of a lemma.
And a theorem, yes. I typed in theorem versus lemma because I don't know the difference.
Okay. To be honest with you, I've never bothered myself to find out the definition for a theorem or a definition for a lemma or even a definition for a definition.
So according to this, it says a lemma is a true statement used in proving other true statements.
Please repeat, my brother.
A lemma is a true statement used in proving other true statements.
Okay.
That is a less important theorem that is helpful in the proof of other results. Yes, that's mathematics. Huh.
Thanks for sharing, Theo.
Thanks, Theo. I've never even bothered by checking the definitions. I don't want to lie to you. But yes.
I know now what a lemma is.
Yes. Do you know what a theorem is now?
It's not as important as a theorem, but it's important.
Yes, it's used to prove other important things.
Okay.
Or it's not as important as a theorem?
Yes, but it's important enough that it's used to prove other important things that are as important as theorems. Okay.
No. Hang on. A theorem states the conditions. Then, in the process of actually showing or proving those statements, we are also showing the correctness or the validity of that statement that is stated by a theorem, almost similar to the definition of this lemma that Theo just shared with us. Is that not so? No. Okay, Lerato, give me any simple theorem that you can remember.
A simple theorem.
Yes, any simple theorem that you can remember.
Can I choose one that's not from maths?
That is not from maths.
Yeah.
Say.
Can we use Pythagoras?
A radius and a second at 90 degrees. Radius tangent 90 degrees.
The angle at this is twice at the circumference.
Tell us what you are saying about the radius, and then what is it that you are saying about the tangent?
A tangent and a radius meet at 90 degrees. Tan radius.
Is that a theorem or a definition?
Theorem, Euclidean geometry.
Euclidean geometry.
Yes.
Can it also be proved?
Yes, you can prove it. You can draw
Oh.
half circle and yeah, you know the
Okay.
prove it.
Okay, thank you. Now, here is another theorem. Theorem 2.3.3. It says a square matrix A is invertible if and only if the determinant of A is not equals to 0.
Ah, yes, we all know this one.
I wish Lebo was here. Lebo has been using this most of the time. She has been saying this.
She's been the advocate for this thing.
Yes, yes. Now let's continue. Okay. This is what Lebo has been good at. Since the first and third rows of A are proportional. Okay. Oh, proportional, yes. One, two, three. First row. Third row is a multiple of the first row. Oh, that's A is not invertible. Is this making sense?
How are they proportional? Like because
Okay, this is what they are saying. In simple terms, this is what they are saying, Larat. And I thought, I didn't expect that question to come from you, because there was a time when you are the one who actually told us that if there are two columns or two rows in a matrix, the determinant of that particular matrix will be 0. Am I not telling the truth by saying that?
row and third row.
Whoa. Let's go back to what I just said.
It's the truth.
There was a time when you said, if we've got two columns in a matrix that are similar, or two rows that are similar, then the determinant for that matrix is equals to 0. Didn't you say that?
I did say so.
Thank you. Now, look at row number 1 in this matrix, and also look at row number 3. Do you agree that row number 3 is a multiple of
Row number 1.
Row number 1.
Yes,
That is what they are saying.
I agree.
Okay, thank you. Theorem 2.3.4, it says, if matrix A and matrix B are square matrices of the same size, then the determinant of AB, the determinant of the product AB is equals to the determinant of A times the determinant of B.
Sir,
Hello?
for the determinant of AB to be equal to the determinant of A and to the determinant of B, there are only two conditions.
Please share them with us.
It's this one. And then there's that one of minusing. The one we started with.
Okay, is this theorem making sense? It says the determinant of the product, meaning you first have to get the product of AB. Then from there, the determinant of the product of AB will be equals to the determinant of matrix A times the determinant of matrix B.
Yes, it's making sense for me.
Okay.
Me too.
All right. Thank you. in terms of the proof, what usually happens prior to the exam? They usually send you a list of theorems to know for the exam. They can send you up to 10 theorems to learn for the exam. From the 10, they might bring 2 in the exam.
Oh.
For you to prove them. Okay. I don't know which theorem will they bring, but usually they send you a list prior to the exam to say, of these 10 theorems, some of them will be in the paper.
Sir,
Hello.
can you use other theorems to prove a theorem?
Another theorem to prove a theorem.
Yes.
Give me a scenario. I agree, but give me a practical scenario.
Let's say you want to prove that n by n matrices, equal matrices can add each other, can add up. I don't know. I don't like proving stuff. That's why proving a parallelogram. And then you prove these 2 triangles, they are congruent to each other.
That is, if that is a theorem,
Then
it can be, if it is a theorem, because Lerado, let me say this. These theorems are not things that we can just talk about while we are having a coffee in a coffee shop.
Okay.
Or drinks elsewhere. They have been proved. They have been proven. Okay? I cannot just wake up and say, no, this house is equals to that dam. That's my theorem. It doesn't work like that. Unless you really prove, then we'll be convinced. Okay, now verifying the determinant of the product of AB. Okay, I've put Abdul's request in the list of questions. Then these are the things that we'll deal with. Let me just talk about over this example. What happens then is to say, you need to get the determinant of A. They got it to be 1. Do you agree?
Yes, sir.
Agree.
Okay. They are telling us that the determinant of matrix B is minus 23.
Agree.
Agree.
Thank you. Now, they come back and they tell us that the determinant of the product of AB, matrix AB, is minus 23. Is that true or not?
True.
It's true.
Now, this has been proved. Do we agree?
50.
According to this theorem. Nomtandazo, are you with me?
Yes, sir.
Makwena, how are you?
I'm good, thanks. How are you?
Are you sure?
Yeah, I'm okay, sir.
You must just talk, man. We miss this voice. You must just
No,
talk.
just-
Even if Even there is nothing to tell us. You must just talk.
I'm just tired. I'm here just to like I'm not here fully, Nje. I'm tired.
What's wrong? You are tired.
Yes.
You can't be telling us that you are tired. We haven't yet even revised for the exam. Now you're telling me that you are tired.
Sir, it's been a rough day. It's been a
it's been a rough day.
Yes.
Okay. So did I. I understand. We are all going through different parts, which are not easy. But please, hang in there. We don't give up, eh? We march forward. Okay. Makwena?
Yes, sir.
We marshal forward. We march forward. All right.
I'm not giving up. I'm not giving up.
Thank you, my sister. Now let's look at this theorem. Theorem 2.3.5. It says, if A is invertible, then the determinant of the inverse of A is equals to 1 over the determinant of matrix A. All right, let me share this little information with you. You see these lemmas, definitions, these lemmas, definitions, theorems. If the examiner doesn't request you to prove them, the examiner will give you several statements to say which one is true, which one is not. Well, with this, we dealt with this yesterday. Now, I want to go not even here. Oh, this is a theorem. Okay. They are saying if A is an invertible matrix, then the inverse of A is equals to the adjoint of A. I wish level was here. It's equals to the adjoint of matrix A over the determinant of A. These are, if it is not an application of a theorem, it will be a statement. Say, I'd give you a number of statements related to a theorem. One of those statements will be true, the others will be wrong. Then you will need to know which one to pick. Okay. We dealt with, I don't think any one of you can, you do know how to find the adjoint, eh? Lebu has been talking a lot about it. Huh? Do you know?
Adjoint of 3 by 3. I don't know.
Okay, how do they get the adjoint, Lerado?
I don't know, sir, for 3 by 3.
You really don't know. Here is the matrix. Adjoint of a 3 by 3 matrix. But you did allow me to pass here. When I said I can be able to handle this, then I just assumed that you understood. Column 1, row 1. Okay. This means that we eliminate row 1 and column 1. Okay. Now let me do this. Abdul.
Okay.
Sir.
Abdul, thank you. Please stay on the line. Kia. Kia.
Hello, sir.
Okay, please stay with me. I'm going to talk to you now. Lerado.
Yes, sir.
Okay, now, Abdul, please prove for us that when we eliminate row 1 and column 1, the determinant is in fact 12. Okay?
Okay.
That is for Abdul. Kia, my sister,
Yes,
please verify that when we eliminate column 2, row 1, column 2, row
yes,
1.
column 2, row 1.
Column 2, this is what is meant by C21, okay?
Yes. Yes.
Using by cofactor method. Please verify that the determinant is equals to 4. Lerado?
Yes, sir.
My brother, please verify that when we eliminate column 3, row 1, the determinant will be 12.
Yes, sir. Yes, sir.
Verify C1, yeah? And then, please verify C22. Please verify
C23, I'm assuming.
We can say after
3, 2 minus 1.
yes.
And then
First row.
Because I know we have 6.
Now we are on the second row now.
1.
Second row is 163.
Okay.
Okay. Third row is 2 minus 40.
Thank you.
Okay.
Ma'am, I'm doing C21, right?
What was it?
Level.
Yes, ma'am. I'm listening.
Level bar we see.
1, 3.
Level bar where we see 1, 3.
Andre, cofactor.
Sorry, level.
Is it a cofactor?
But
Yeah.
is it a cofactor? Yes, but is the cofactor method level?
Yes,
get the
ma'am, I
determinant.
understand.
Okay, level arwa understand. Yes, Namtandazo.
I'm getting the determinant or cofactor.
Level R, is he supposed to get the determinant or cofactor? Is the determinant level?
Okay, ma'am, thank you.
You are using cofactor method level to get the determinant.
Okay.
So we only confirm those 4 only.
No, I'm lost, guys. Can I get the assistant? Yes. So like get a
Yes,
C13.
level.
I'm doing C13. So C13, I'm eliminating. Yes, I'm eliminating row 1 and column 3, right? And so,
row 3, column 1.
Sorry?
You're eliminating row 3, column 1. Aren't you doing 3, 1?
I'm doing 1, 3. Is it 1, 3?
Oh, yeah. 1, 3. You're eliminating row 1, column 3.
So I'm using row 1 or I'm using column 3.
You're eliminating row 1, column 3, and then you you calculate the determinant of the matrix that is left.
Lebu.
Oh, it's like I'm getting cofactor. Like I can't understand because you are talking about determinant, then cofactor. Like I'm getting a cofactor of 1, 3.
Yes.
Okay.
By calculating the determinant.
By calculating the determinant. Yeah. My answer for C13 is 16. Negative. No, it's positive. I'm getting positive.
It should be negative because
Mr. Matuso or Theo. Let's give Mr.
Okay,
Matuso a break, Theo.
Okay, I think I can go and be the leader of our first one.
Please.
If I remember very well, now I was doing first row, first column.
All right. Thank you, Mr. Matuso.
And I was supposed to prove that the determinant of that cofactor is 12. So if I'm to repeat the matrix that we have just to make sure that everyone is following, our first row is 3, 2, and -1. Our second row is 1, 6, and 3. And then our third row is 2, -4, and 0. So looking at the fact that I'm doing row 1, column 1. So if you scratch out row 1 and you scratch out column 1, you'll be left with that sub-mini matrix of 6, 3 on the first row and then -4 on the second row. Finding the determinant of that matrix, it's going to be 6 times 0, which is 0, minus, and then you will have -4 times 3. I mean, -4 times 3 is -12. So therefore, we will have 0 minus -12. And then 0 minus -12 is 12. And therefore, that's how the determinant of the cofactor for the first row, first column is 12. Do we agree, colleagues?
Agreed.
Oh, yes, I agree.
Okay, Lerato?
I agree.
Lebu?
I agree.
Okay, thank you very much, colleagues. I'm not sure who's supposed to be doing C1, 2. Or Lerato, what are you doing? Which determinant or cofactor were you supposed to be finding?
First it was 1, 3, and then said changed it. So I just did everything.
Okay, so you can go ahead with 1, 3, it's okay.
Okay. 1, 2, I cancelled out the first row. 3, 2, -1, and then I cancelled out second column. 2, 6, -4. I was left with 1, 3, 2, 0. 1 times 0 is 0 minus, I think, 3 times 2, which gave me -6 instead of the 6. So -6.
Okay. But remember, your answer is supposed to be +6. Do you know why?
Why?
So you remember when we calculate our cofactors, basically, to the long and short of it is that, because Anita, you said you got -6.
Yes.
But if you look at Sir's answer there by the textbook, it's supposed to be +6. And the basic explanation for it is that basically the signs alternate. So they go from, we're going to start right at the corner and we move towards the right. So it's going to be plus minus. So the reason why Mr. Abdul's answer was a +12 is simply because he got a +12 multiplied by basically +1, and then it stays as 12. Whereas for the second entry in the same row, that answer must be multiplied by a negative value. So if you got a negative and you multiply by a negative, basically -1, then what does that become? It becomes a positive.
Oh.
Yes. And then for the third entry in the first row, whatever answer that person's going to have, they multiply it by a positive. And then if it's positive, it'll stay positive. And then if it's negative, it will still stay negative, because a negative times a positive is still a negative. I hope what I'm saying makes sense.
Makes sense.
Okay, cool. That's why. I hope now you see why. But yeah,
This
thanks.
this -6, it's a minor.
Yes.
And then you multiply it by -1 plus n plus 1 there. What.
Yes, that thing, yes. And then we get our cofactor, yes. And then we build the cofactor matrix afterwards, yes.
Okay, it's fine then.
Cool.
Theo,
Yes.
can I ask something?
Yeah, sure.
If a question comes saying, find the determinant of a 3 by 3 matrix using cofactor expansion, ne?
Yes.
You only start with first row, first column, or you can start
You can start wherever you're comfortable, honestly. You still get the same answer either way.
But then if I start by, for example, let's say I start by row 2, column 1, how will my signs alternate? How will I do that? Because I only know how to do it when I start by row 1, column 1.
Well, okay, so let's say we've got again, I stand to be corrected, but what I would then do is because you asked me what happens if you start with row 2, column 1, right?
Yes.
Well, again, for me, the method, how I would approach the situation is if we've got a 3 by 3 matrix, my methodology would be, okay, sharp. In fact, no, can I say something? Just to make sure. So when you say you start with row 2, column 1, you would basically, now in case of this matrix, you would work from 1, then move on to, so you cancel 1 first, then cancel 6, then cancel 3. Is that what you're saying?
I just wanted to know if it works like that, or I start with.
Yes, I know, but I mean, just like again, let's try use this example so that we can try follow what you're saying. So what you would be doing is instead of canceling from row 1, column 1, and then moving to the right, you would start canceling from row 2, column 1, right?
Oh, okay.
No. Don't leave.
Makes sense.
Are you sure? Because I was still okay. Okay, cool. If you say it
No,
makes
you can
sense.
proceed.
Okay, so again, in terms of the signage, remember when we're working from, let's say, top left and moving all the way to the right. So in this case, if we're working from row 1, column 1, and then making our way via the right. So we do row 1, column 1, then we do row 1, row 1, column 2, etc. In your case, we would be working from row 2, column 2, and moving to the right, right?
Yes.
Yes, in terms of the signage for you, then you'd have to look at it in the sense that, again, the signs always alternate. So you'd always have to have a plus minus, which then means that your first sign would then be a negative. Because if you look at it from row 1, column 1, it would be a plus. Then if you go down to where you were, it would be row 1, column, it would be row 2, column 1, which would then be a negative. Do you see what I'm saying? I hope I'm making sense. I hope I'm not confusing you even more, because if I am, then somebody else can explain it.
No, I understand. So is it possible to start from row 2, column 2?
I don't know, because my thinking would always be you always want to start from like an end and move to an end.
Yeah, you're supposed to. Oh my goodness.
Yeah, you start from an end and move to an end. You don't want to start at a random point. So you can start anywhere as long as wherever you're starting, you start from one corner and you move to another corner. I always think that makes better sense, I think, honestly. Because then it's by doing it like that, you've got a lesser chance of actually getting yourself confused in the end.
Okay. Thanks.
Yeah.
Thanks, Ne.
Sharp.
Yeah, okay, I was supposed to find the cofactor of the 13, 13. And then I got positive 16 firstly. Then someone explained, is it Theo? I'm not sure.
Yes.
Explain that if you got a positive number, you are supposed to multiply by a negative number.
No, well, you said you were working on row 1, column 3, right?
Yes.
So row one, column 3 would then be multiplied by a positive number. So if your number was negative, it's going to stay
Yeah,
as
so
negative.
my minor.
Yes.
16 is my minor, yeah. And
Is it positive or negative
to
16?
multiply that minor with a -1 to the power 3.
Okay.
Am I correct?
Yes.
Now, -1 to the power 3. Infinite -1.
Yes.
Mm.
And then -1 times 16.
Yeah, times 16 gives me -16.
Yes, which is correct.
Okay, thank you.
Sure.
Thank you. Ken, Theo, thank you. Are you the one who was holding the fort for me?
No, it was all of us, sir. It was all of us.
Oh, okay. Thank you, everybody. Thank you, everybody. Now, Abdul.
Yes,
Abdul. What did you get to be C11?
I got it to be 12, sir, as I explained to the family already, to say that if you were to cross out row 1 and column 1, you'll be left with that mini submatrix, which is a 2 by 2. First row will be 6 and 3, and then second row will be -4 and 0. When you multiply 6 and 0, you will get 0. And when you multiply -4 and 3, you get -12. 0 minus -12 is +12, and that's how our C11 is 12.
Thank you, brother. Kia. Kia.
Hello, sir.
Kia.
Hello.
What did you get to be C21?
C21.
Mm-hmm.
C21.
When you eliminate column 2 and row 1, what did you get?
Column 2 and row 1.
Mm-hmm.
I get 6.
6.
It's column 2. It's
column 2, row 1. That's what I request.
Yes, when you told column 2 and row 1, you left with 1, 3, 2, and 0, right?
Let's see. Column 1, column 2, column 2, and then column 2, row 1. Yes, you are left with 1, 3, 2, 0.
Yes. Then that's as -6, because 1 times 0 is 0, and then 2 times 3 it's 6, and then 0 minus 6.
So you're having a 4 year. Yes, someone
That's
is talking.
the thing. That's what I was worried about. How is it that you're having a 4? So it means the 4.
It's row 2, column 1.
Yes. No. Says at column 2, row 1. So when it goes column 2 and row 1, that's what I did. Hello?
Lerato?
You are reading it wrong. It's row 2, column 1.
Who's reading it wrong?
It's row?
Wrong.
Who's
Row
reading
2,
it wrong?
Column 1.
Who's reading it wrong?
You and
no,
it's okay.
The instruction was column 2, row 1. So I did for column 2, row 1, and the answer is 6. That's for column 2, row 1. So if it's row 2, column 1, then it will be something else. Then it will give us a 4. Definitely will get a 4.
A negative.
Please come in.
Like say.
Yes.
It's row 2, row first, column after, like A21. Yes. And then
what is happening with me?
Yes, and then you'll get -4 as a minor. And then -1 times -4 is +4. I agree with what Gia is saying. As not
Gia. Thank you, Lerato. Gia.
Sir?
Remember my request earlier?
Yes.
To you.
Yes.
Please don't be surprised when we're in this situation. Okay?
No, yes, you're not wrong. I gave out the correct answer. So
yes, you did what I requested you to do.
Thank you, sir.
Thank
you.
But now, I'm now coming back to say, do you remember what my request to you was before I requested you to calculate this earlier?
Yes, it's similar to the request that I did on Monday. Was it Monday or Tuesday?
Yes. So that is the reason. Please bear with me. Okay.
Not a problem, sir.
Okay. That means I'll request everybody to bear with me. Okay. That was Kia. Even Lerado. Let me check with Lerado. Lerado, C31.
You gave it to me.
Yes.
Okay.
According to my according to this paper of mine, that is what I requested you to do.
So C31, you get a matrix of 2, -1, 6, and 3. And then 2 times 3, it's +6. Times 6, it's -6. And then 6 is +12. And then 1, I don't know how it happens. -1, 3 plus 1, it's -1 to the power 4, which will give you +1. +1 times 12, it's 12. Yeah.
We agree with the 12, no?
Yes, we agree.
Thank you. Magwena. 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 Lamidelia. Kia, is Magwena here? Lebo, is Magwena here?
Let me see, sir. Network problems. This low shading. Makwana is not here. Makwana is not here.
Makwana on.
Gone.
Okay, thank you. Now, let's double check C12 together. Now, that means we eliminate row 1 and column 2. Then we'll be left with 1320. Do we agree?
Yes, sir.
We eliminate the row 1, column 2, 1320. Therefore, that will be 0. 1 times 0 is 0. 2 times 3, it will be, that will be -6. Is it -6 or +6?
So which one are we doing?
It's the
we're doing.
Is it a positive?
C12.
Row 1. We eliminate row 1 and column 2.
Yes,
row
sir.
1. We are left with 1320.
Yes, and then it's 1 times 0, which is 0, minus 6.
Minus.
It should be a -6.
Yes.
It should be a -6.
But
here they wrote
but the
+6.
final answer is a +6, right?
No, how so?
Yes, it is. You know what? No? Actually, can I? Okay. I know why you were like it should be a -6. I just posted my solution to the group, and I hope this is gonna help because it confuses us sometimes, even me. So I had to do something different, but same principle. Okay, hope this thing is sent because of the network.
I think I see why is it a +6.
But check out what I posted on the group because I was supposed to do C23. Do you see it?
We multiply -1 to the power 3.
Yes.
And then, what about that 3 in this case, in the case of the adjoint, Theo?
Sorry, sir. What are we talking about?
Okay. Let's start from the beginning. Let's get this thing right from the beginning. Okay.
Yes.
We'll come back to this. Let's do this together.
Yeah.
Let's start with C11.
Yes.
We get rid of row 1 and column 1.
Yes.
So we are left with 63 minus 40.
Yes.
Then 6 times 0 is 0.
Yes.
Then we have got minus 12. But
minus,
now
minus 12.
Minus 12. Yes.
Yes.
But ideally, I need to check something. Remember when we find the determinant, ne?
Yes, sir.
It will be when we get rid of row 1 and column 1, then it will be that 3 multiplied by minus 1 to the power 2. Row 1 plus column 1.
Yes.
Are we together?
Yes.
So now, in the case of the adjoint, do you see that that 3 hasn't been taken care of? Is not considered. Now, let's go to the next one. We'll go back to that where they've been explaining this aspect of the adjoint. Let's look at the next one, C21. We get rid of row 2, column 1. But
Sir,
then, yes.
Can I ask for something strange?
Yes.
Because I get the feeling that we are following you, but not all of us might be following you completely. So do you mind if we do C23? And I'll tell you why. I posted the whole thing on the chat because I feel like if we can all see, yes.
C23.
Let's do C23 and then we can go back to where we were, because I feel like if people, well, if the rest of the colleagues can see the visual aid, everything else is going to make sense.
Okay. Now, let's go to, you say C23, ne?
Yes, and I posted it on the chat. So if the people, if anybody's not sure, can they please just check the chat? I posted the picture on there.
Okay, now let me talk over it.
Yes.
We get rid of row 2,
column 3.
Row 2, column 3.
Yes.
Our matrix is 3, 2, 2 and minus 4.
Yes.
Then we will have minus 12.
Minus 4.
Minus 4.
And that is minus 16.
That's minus 16.
Yes.
Okay, I'm trying to see something here. Now, remember, it's row 2, column 3.
Column 3, yes.
Now, there is, what we are considering is that 3, okay?
Yes.
Now, that 3, let me say this, but then I'll come and repeat what I just said.
Okay.
When we get the determinant, that 3 where it's sitting, it will be minus 1 to the power, row is 2, column is 3. That means it will be minus 1 to the power 5.
Yes.
Which becomes minus 1.
Yes.
The pattern that I'm noticing here is to say we are only considering the position of 3. Are you with me, Theo?
Yes, sir. I'm with you.
It is minus 1 to the power. That 3 is in row 2.
Yes.
Column 3 is minus 1 to the power 2 plus 3. Minus 1 to the power 5 is minus 1.
Yes.
That's why it is positive 16 instead of being negative 16.
Yes, because then we multiply the negative 16 with a negative 1, and that gives us positive 16. Yes.
Yes.
I hope this clarifies everything, because this thing tends to cause confusion, even for me sometimes. But I feel like when I do it like this, it's okay.
Please talk to, okay, now, please ask everybody whether they follow just on this C23.
Yes,
before we can go back.
Colleagues, do you follow?
I'm lost.
Okay, can I try explain it to you?
Yes.
Okay, are you looking at the thing that I posted in the chat?
No, should I go there?
Yes, please go to the chat. I posted my solution to the chat. I'll explain it to you, and I think this is going to do the trick.
Okay.
Yes. Do you see it?
Oh.
Can we do it together quickly?
Yeah.
Okay, so basically said I must find the solution for C23, right? And C23 is basically row 2, column 3. And the value in row 2, column 3, you see I haven't put an asterisk next to it, is a 3, right?
Yes.
Which then means we're going to cross out all the elements in row 2, column 3, and that leaves us with basically the minor of 3, 2 to negative 4. Are you following there?
Yes, yes.
Okay, cool. And now we calculate the determinant for that. You know how to do that. And determinant is basically going to be 3 times minus 4 minus 2 times 2. And that gives us basically negative 12, negative 4. Are you with me there?
Yes.
And now, remember, we are getting the cofactor. And now what we have to do now is once we get that number, we're not done. We have to do one more step. And we basically multiply that number that we have with minus 1 to the power of whatever value we're looking, whatever position our value was in. So you know how my position is 2, 3. So you add the 2 digits. So it's going to be minus 1 to the power of 2 plus 3. So if you're looking for 2, 2, it is going to be minus 1 to the power of 2 plus 2. Are you with me?
Yes, yes.
Yes. And then in this case, then our answer is, remember we're at the negative 16, and then we multiplied with negative 1 times to the power of 2 plus 3. And what negative 1 to 2 plus 3 is negative 1 to 5. Negative 1 to the power of 5 is negative 1, right?
Yeah. Also, I was actually finding the minor, not the cofactor.
Yes, yes, yes. But if Sir will allow, I would like to show everybody in the group an easier way to do this thing. But that's if he's okay with
it. Let's say for now, okay. I'm okay with you doing that, Theo. Let's now following this, make sure that everybody follows this. Then you will come back again, Theo.
Okay, sir.
Now let's just do what? Let's say, because if I remember, okay, let's just do C33.
Okay.
C33, all of us, please let's pay attention. Meaning we get rid of row 3, column 3.
Yes.
Okay. Then the determinant for the remaining matrix will be 18 minus 2. Okay. Which is 16. Then where there is that 0, remember it is row 3, column 3. This row 3 and column 3, they are meeting there at 0. At that 0, we are multiplying by minus 1 to the power row is 3, column is 3. Or if it makes sense to you, you can just take it straight from this C33. It's just minus 1 to the power 3 plus 3, which is 6, which becomes positive 1. Are we clear? Let me go to C32. Are you still with me? Hello?
Yes, sir.
Okay. Now, C32. We get rid of row 3, column 2. Where are we meeting? We are meeting at minus 4 in row 3. All right. What are we left with? We are left with 3 minus 1 and 1 and 3. Then what are we having as the determinant? Is 3 times 3 is 9 plus 1. Now That should be what? 10. But now we are having this minus 4 is in row 3, column 2. Minus 1 to the power 3 plus 2 is 5. Minus 1 to the power 5 is minus 1. That is why it's minus 10. Are we all clear?
Yes, I'm clear. Colleagues?
Please ask everybody if they are clear.
Colleagues, please comment.
Sir,
Yeah, okay.
Yes, Lorado.
there's something which like I've been trying to think. The difference between a minor and a cofactor is the symbol.
Is the symbol, but in this case, what you are only considering, you are considering the position where you are eliminating, where there is an, at the intersection of a row and column.
Okay.
Then minus 1 is raised to the sum of that row and column. But we are now not considering that number like when we get the determinant. Remember, when we get the determinant, we consider that number. That number is multiplied by that minus 1 to the power of the sum of a row and a column.
Okay. For example, if we're doing the determinant, you're gonna put 3 in front of the smaller 2 by 2 matrix. But
then that 3, you will put a minus 1 in. It will be that 3 multiplied by minus 1 to the power row, this minus 1 in bracket to the power of the sum of a row and a column. That 3 is in row 1, column 1. So it will be minus 1 to the power 1 plus 1, which is minus 1 to the power 2. Then you multiply by that 3. That number will be multiplied by the determinant of the matrix, of the 2 by 2 matrix that you find.
Okay.
Theo, please come forward.
Okay, thank you. Okay, so again, while I was scouring the internet and YouTube and everything, the problem is in the exam, we are always kind of pressed for time. So I found a quicker way of doing this. And I think it's also going to make it easier for people to compute this thing. But again, like with most things, I always advocate for people to first understand the fundamentals, and then we can talk about shortcuts. But anyway, I posted this thing on the group. Yes, it's on the group. So if you guys would be so kind as to check out the thing I just posted. Okay, so basically what we do, and again, I might have gotten some of the signs wrong, but I'm sorry about that. What we basically do is to compute your adjoint, you would compute all your, what can I say? You would compute all your cofactors. I hope that's the correct word. So basically you calculate all your mini determinants and then you get your numbers. And then what you do from there, instead of multiplying everything by minus 1 to the power of whatever, what you then do is you multiply that whole matrix that you've formed with the new minors with what you see there I've put on the right. So basically, if it's a 3 by 3 matrix, you will start with a plus minus, and you go all the way till the end. And then you multiply whatever you got with whatever the sign is in the corresponding matrix. And then it always works. Then it always gives you whatever your new number and sign should be. So if you had 12, after you worked out your new matrix of minors or cofactor or whatever it's called, let's say for this, if it was 12, you're going to multiply the 12 with a positive and you end up with a positive 12. And then if your 6 was a positive, you'd multiply it with a negative and then you'd get a negative 6. I hope what I'm saying is making sense, basically. Yes, I see I made an error with some of the signs, but basically it always works. Where if you had a 4 by 4 matrix, then you in your first row, you would multiply that first row with plus minus, and then when you get to the second row, because you ended up with a minus, the first entry would then be a plus. Then you multiply whatever you got with the corresponding sign in the other matrix, and then it just basically helps you get the whole thing in the end. Because I get the feeling eventually it gets kind of confusing when you're going to be multiplying whatever you get with minus 1 to the power of 1 plus 2, or minus 1 to the power of 2 times 2, especially in the exam where you press for time and you're trying to do it quickly. So you could try this. And if it works for you, great. If it doesn't, you can do it the way that we've been taught.
Thank you, brother.
Yes, sir.
Now, can we continue? Then, after that, we take all those, we put them in a matrix. Let's see, that's 12. Lerato, where are you?
I am here. Watashibai.
Okay, please help me out here.
Okay.
C11 is the 12 that we got, okay?
Yes.
C12. You and I agree. Lerato, remember, you said to me, and I agree with you, is row first, followed by a column.
Yes.
Oh, okay, now I see. This is the first row, coming from the first row, okay? This is coming from the second row. And this is coming from the third row. Then in the adjoint, a row is becoming a column.
Transpose.
Transpose, yes. A row is becoming a column, row is becoming a column, and that's it.
So say,
yes.
If matrix A, the transpose of matrix A, is its adjoint.
Your question again?
Transpose of A, it's the adjoint of A.
Before I respond to you, Level, are you here, my sister?
Say.
Who's talking? Is it Namtandas?
Yes, can I please try and respond to Lerato?
Yes, please.
The adjoint is the transpose of a cofactor.
So you have to find cofactors first.
Yes, then transpose the cofactor.
For any matrix, including a 2 by 2, it's the same system. Find cofactor, transpose it.
I'm not sure about 2 by 2. I'm sure about 3 by 3.
Yes, Nomtandas, I agree with you. The adjoint is basically the transpose of the cofactor.
Hello, sir.
Hey, where have you been?
Load shedding, sir. I was busy. I had many assignments, but the load shedding at 5, my laptop will be.
She's come back from the darkness.
Thank you.
Thank you, Tando.
Okay, so I have the person.
Yes.
Yeah, for Lerato.
Okay. Go ahead.
Yeah, I think the transpose of C is equal to the adjoint of A. We can't separate it. I think it's the same. But now, what I discovered when I'm finding the inverse, because there's this formula where they say 1 over adjoint of A. So I'm not so sure, but I heard Nomtandazo and Theo what they said. So I just want to be sure. Am I wrong if I say the transpose of C is the adjoint, as Lerato said?
I'm trying to understand. Please repeat your question, Tando. Before you come in, family, let's pay attention to what Tando is saying. Go ahead, Tando.
I'm asking about the cofactor. The C transpose is the transpose of the cofactor that we got there, C11. Then when they say the adjoint of A there, on my side here, I say it's the transpose of C. So, but now the question that Lerato asked, I'm so confused now. Because here on my answer, I said CT, the transpose of C is equal to adjoint of A, which is equal to the last answer there, 12, 4, 12, 6, 2, negative 10. So am I wrong or correct if I say the C transpose is equal to adjoint of A? That's my question.
Okay, Tando, let me try to respond to you. This is what we said. The pattern that we have observed here is to say, after finding the cofactors, then remember those cofactors, we find them from the rows. Okay? Look here. Are you with me? Do you see what I've highlighted here?
Yes, sir.
Okay. C11 is coming from row 1, column 1. C12 is row 1, column 2. C13 is row 1, column 3. Do we agree?
Yes, this one I got it.
This means should be in where? In a row. You see, the matrix below, 12, 6 minus 16.
Yes.
But now, the adjoint is the transpose of the cofactor matrix.
Okay, yeah. So now,
meaning after getting the cofactor matrix, we get the cofactors, we plug them as they are in a matrix. Then from there, we transpose. That transpose is the adjoint.
Okay. Now,
Sandra,
hello.
that says there stands for cofactor. I don't know if it's necessary to say.
Yeah, see, I know, but I used to just write it as CT. So that what I wanted to know is that, am I okay? Am I correct if I say cofactor, the transpose of our cofactor is equal to the adjacent of A?
Oh, okay. Yeah, you are correct.
Have you been answered, Tando?
Yes, sir. Thank you so much.
Nomtandazo? Thank you very much. Thank you very much for helping a sister. Thank you very much. Can we step off this one?
Yes.
Okay.
Yes.
Let me come to this definition. Or maybe before this definition, okay, we did talk about this theorem to say the determinant of the inverse is equals to 1 over the determinant of a matrix. Now, here. Now this definition must clearly make sense to everybody because we have seen its application. This definition says, if A is a square matrix and Cij is the cofactor of Aij, then this matrix is called the matrix of cofactors from matrix A. The transpose of this matrix is called the adjoint of A. N is denoted by the adjoint of A. This is what we have been doing. Do we agree?
Yes.
Is this making sense to everyone? Is this definition now making sense to everybody? Lerato, please ask them.
I agree.
Thank
Yes,
you. Okay, thank you. Lebo, is Lebo here?
She's gone.
She's gone. You know why I'm asking Lebo? You know, when we talk about the adjoint, Lebo likes that.
Too much.
Yes. That's why I kept on calling her name. Now let's look at this theorem. This theorem says, inverse of a matrix using its adjoint. If A is an invertible matrix, then the inverse of A is equal to the adjoint of A over the determinant of matrix A. Please know this theorem. Now, yes.
This thing is the one we did most before with 2 by 2s when we're doing inverses.
Yes.
Okay.
I agree with you. I agree. Now, here they are saying using formula 6 to find the inverse of the matrix in example 6. Where is that example 6? This is example 6. What are they saying? Are they telling us now? They are saying the inverse is equals to the adjoint of A. We know the adjoint, eh? This is the adjoint over the determinant of A. We get the determinant of this matrix. I know some of you might start to panic, but at least there is a 0 there. That makes it less work for us to be able to calculate the determinant for this matrix. Can we now all just confirm that the determinant for this A is in fact what they are telling us here to be 64? Please. How many minutes, Lerato?
What's A first?
What we are looking for is the determinant of A. Okay. Now, here is my advice to you. Please expand along row. Okay, either row 3 or column 3.
Okay.
So we are finding the determinant, right?
The determinant for this for matrix A, yes.
Okay.
It must be 64.
That is what they are saying. We are just verifying it. Please, let's verify it.
Okay.
So,
hello, Nomtandas.
Can Lerato please expand along road 3?
No.
Please. And can he explain how he did it?
I'll do it. You said row 3, right?
Yeah, row 3.
Okay, I'll do it.
Whether you expand along row 3 or column 3, it will be easier for you because of that 0.
Okay, can you expand through row 3, column 3 and explain to me? I want to see how they do it in row 3, column 3.
You want to see how they do it?
Yeah. So can they please explain?
Namtandazo, are you saying you are unable to do it?
I can do it along row 1, column 1. So I want someone else to do on row 3, column 3 and explain.
The answer will still be the same.
I know, but I want to see how they do it. I think that confuses me there, and if they explain, I'll get it.
Okay.
What's the answer? Sir.
Hello.
36 plus 36 plus 22.
36 plus 22.
Plus 20. Yes.
Hang on. 36 plus 22. That's 58.
Yes. Sorry, I did a mistake somewhere. Sir.
Hello.
I'm done.
The answer is
Thank
you.
Thank you, Theo.
Sure. So just to confirm, what?
Okay,
never mind, it's fine. I'm done. It's fine.
Lerato, you were still talking.
The answer is supposed to be how much?
59.
No. Definitely not.
Yes, Theo. Yes. Yes, I know. I know.
What's the answer, Theo?
Yeah?
Don't say it, Theo. Please.
Yes.
What are you getting, Lerato?
It's happening again.
Yo.
What?
Yesterday is happening again.
Because like I cannot get 58, man. I swapped some.
What are you getting? What are you getting?
58, man.
Is that what you are getting?
Wait, sir. What are you calculating here?
The determinant.
Of which matrix?
Matrix A. Do you see matrix A? Do you see my screen?
6, 3, negative 4, 0. 1, 3, 2, 0. 1, 6, 2, negative 4. Oh yeah, I get it. 6 times 2 is 12, ne?
Yebo.
Yes.
It's negative. Who's this individual? Busy here, embarrassing us. Yes.
Sorry?
Like I did like 6 times 2. I said it's 6. I don't know how. Like it's happening again. I said it.
Then what did you get now?
16, and then 36 plus 12 plus 16, 64.
Yes, good man. That's the one.
Okay. We agree that the answer should be this.
64.
64.
Yes, sir.
Yes. This is the adjoint that we found. Then the determinant of that matrix A should be 64. So it's 1 over 64 multiplied by this. Then what they did, then they just brought in what? The 1 over 64 into the matrix. This is what they ended up having. Is it clear?
Yes. Namtandazo, are you okay?
No, I'm still waiting for explanation.
I'll do you one better. Can I post it for you on the chat so you can see it step by step?
Yes.
Because I need you wanted me to expand along row 3, right?
Yes.
Okay, give me like 2 seconds. Well, more than 2 seconds. Give me like 1 minute. I'll post it for you now.
Okay.
Hopefully this helps.
You can proceed, say.
Without you.
I will check it, say. I also got 64, but I used row 1, column 1. So I'll check how they do it on row 3.
Check it now before we continue, so we can all continue together.
Sir,
Hello?
when you use row 2, you just put 1 in front, and then you write 2, -4, -1, 0 as the first matrix.
Yes.
So it's the same thing, just at different lines.
Yeah, same thing. Yeah.
I've
This
seen
is
things.
it's row expansion, this one.
No, Mtandas, my sister,
Yes, sir.
do you follow?
Yes, 100%.
I don't want to leave you behind.
I'm now sorted, sir.
Thank you. Now, please, let's talk about Cramer's rule. Cramer's rule. Okay. Let's look at this theorem. Theorem 2.3.7. If AX is equals to B, is a system of n linear equations in n unknowns such that the determinant of A is not equals to 0, then the system has a unique solution. This solution is x1 is equals to determinant of A1 over the determinant of A. X2 is equals to the determinant of A2 over the determinant of A, up to xn, which is equals to the determinant of matrix AN over the determinant of A, where AJ is the matrix obtained by replacing the entries in the jth column of A by the entries in the matrix B, which is equals to B1, B2 to Bn. Straight. If you are confused here, now let me clear that confusion. That confusion.
Gabriel.
Eh?
Oh, it's Gabriel. Okay.
Yes, it's Gabriel.
Gabriel. Okay. Thank you, sir.
Yeah. Right. So now, hello.
Like, is this the one where you take the B and you put it inside the matrix?
Correct. That's it.
But the definition is not saying so.
Sorry, there?
I don't get how in the theorem they explain the B moves inside the matrix.
Okay, don't worry. You'll get to see it. Don't panic, please. Ne? Dorado?
I'm not panicky.
Okay, please don't panic yet.
Yet.
Yes. So remember from that section that we dealt with, the one where we dealt with inverses of matrices.
Yes.
You still remember AX equals to B?
Yes, I remember it from assessment.
Yes. And then when we solve for X, then we first have to get the inverse of A, then multiplied by B. Now,
it appears.
yeah. Now let's look at this example here. Using Cramer's rule to solve a linear system. So they are saying the system that we are given is x1 plus 2x3 equals to 6. minus 3x1 plus 4x2 plus 6x3 equals to 30. Minus x1 minus 2x2 plus 3x3 equals to 8. So, in simple terms, what Kramer is saying is that, first of all, you see from the matrix on the left, from the unknowns.
Yes.
From the left-hand side, then you form a matrix, which is 1, 0, 2, minus 3, 4, 6, minus 1, minus 2, 3. Is it clear?
Yes, it's clear.
Okay. And then from that, A. From the left-hand side, you form a matrix, which is A. Then you get the determinant of this matrix A. Okay.
Yes.
Then from there, after getting that determinant, the next thing that you do, you see the first column in matrix A. Do you see the first column in, do you see matrix A?
A1.
Whoa. Matrix A. Do you see matrix A?
Yes, I can see.
Yes. Then you take what is on the right-hand side. You replace the first column. You call that matrix A1. Okay.
Okay.
Next, you take what is on the right-hand side. You replace the second column. You call it A2. Lastly, you take what is on the right-hand side. You replace the third column. Then that is our A3.
Yes.
Am I making sense?
Yes, you are, sir.
Okay. Then from there, from A, we get the determinant of A. All right.
Yes.
We get the determinant of A. Oh. Yeah, let me do this. Please, don't fight me. Don't fight with me. Maybe let me request. How many are we here? Lerato, please tell me who's here. Is yourself?
Yeah. There is Tandolo Ishe,
There is Tando. Yes.
Nomtanda.
Nomtandazo. Is yourself? Le Tando. Nomtandazo.
Theo. Glenn.
Yes.
Like there are 5 learners there. From what I see.
Okay. This is more than enough. Okay. Okay, it is Lerato, is Tando, is Nomtandazo, is Theo.
And Kamohit.
And Kia.
Let's not forget Kia. Let's not forget Kia.
Okay, and Kia. Now, my boss will help me. Who wants to calculate the determinant for matrix A?
Lerato.
Thank you. I'm attaching your name to A. Who wants to calculate the determinant for A1?
Theo.
Tando.
Can I do A3?
Okay. Theo will be A3. Okay. And now we have got Tando, Nomtandazo, and Kia. Please choose.
Nomtandazo will do A3.
Nomtandazo
A1,
will do
Tando.
Okay, whoa, Nomtandazo. Okay, Nomtandazo, you are doing A3 with Theo, ne?
Oh,
Because Theo has already chosen it. It's okay. Okay, then Nomtandazo and Theo are on A3. Now, we are left with Tando and Kia. Tando, which one are you choosing?
A1.
A1, thank you. Kia. 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 Kia.
O phamisitse letsoho marabung.
Huh. Please ask her to talk to us.
Kia, talk to us.
Will you sign language if you want us to do that? But now we are requesting you to talk to us.
No, my mic is not working.
That's
Oh, okay. Now, let me reshuffle. Let's make a reshuffle here. But it's not that one for Parliament. Eh? It's not cabinet reshuffle. Now, let me pay Kia with Theo. Okay?
Yes.
Kia and Theo will be on A3. Nomtandazo. My
yes,
sister.
sir. Yes.
Then I'm requesting you to calculate A2. Okay.
Okay.
Yes. The reason being that Kia is having a mic now, will have a challenge in communicating. So, Lerato, we're calculating determinant for matrix A. Tando, matrix A1. Nomtandazo, matrix A2. Theo, matrix A3. I mean, Theo and Kia, matrix A3.
Lerato is done.
Okay, now let me write here. Lerato, what did you get, my brother?
44.
Please double check it. I'm writing it down, but please double check it.
I did it already. 44.
Okay. You can double check. Oh, you also double checked, Lerato.
Yes, I always double check my work now because I have an issue.
Okay, let's wait for them.
Yeah.
To calculate A1, A2, and A3.
I'm done, say with A1.
What did you get, my sister?
Negative 40.
Please double check it. I'm writing it down, but please double check it.
Okay.
Namtandazo, what did you get?
72.
That is for A2, ne?
Yes.
Please double check it. Can anyone hear me?
Yeah, no, I can't.
She says her network slow or something.
Makwena wrote on the chat, posted something on the chat.
That's for 64. The answer of 64.
Thank you, Magwena. Oh, she's still where we were.
No, sir. Sir.
Yes.
I want to change the answer.
Sorry?
Sir, 24
Yeah.
plus 20. It's 44.
44.
24 plus 20.
Yes, and if you got 44, you got the correct answer. Even I will tell you. I worked it out as well.
Oh,
So
you did everything.
No, I just did the first one and my one. That's all.
So Magwena got 44 for which one? For A.
64 for A, the first one, the one before, I think. Let me double check.
No, that was
Please do.
before. That was before I could I could get out of it. I don't know how to put it. English ran away.
Or is the previous exercise that we were working on?
Yes.
Okay.
Away with the load shedding.
Okay. Magwena, thank you. That is the answer that we were looking for.
So now what are we doing?
Here, we have moved, we are now on Cramer's rule.
Yes, okay.
Let me take you back for a few seconds. That 64 that we were looking for was for this matrix, né?
Yes.
Yes. Then from there, we came here. We said, okay, we calculated the adjoint. You were here while we were calculating this adjoint, eh?
Yes.
Yes. Then now it is 1 over the determinant of A. That is why we're calculating the determinant of A. It is just 1 over 64 that you found. Then we apply it, or we multiply it by this adjoint to get this matrix.
Okay.
Is it making sense?
Yes, sir.
Thank you. Now, we moved. We are now here on Cramer's rule.
Sir.
Hello?
Kabetri.
Okay.
Kia says what? 2 minutes is up, ne?
Yes.
Oh, there's still additional 2 minutes.
No, it's done. 2:36.
2:36.
Yes.
Okay. Let me briefly explain to Magwena. Magwena, are you here? Lerado, is that ghost of Magwena still here?
Yes,
or is
sir.
she gone?
She's here.
Oh, she's not a ghost. Okay. Magwena, in this theorem 2.37, we are looking at Cramer's rule. Cramer is saying if AX is equals to B, is a system of n linear equations in n unknowns, such that the determinant of the given matrix, which is A, is not 0, then the system has a unique solution. Then this solution is given by x1 is equals to the determinant of matrix A1 over the determinant of matrix A.
Yeah.
X2 is equals to the determinant of matrix A2 over the determinant of matrix A, up to xn, which is equals to the determinant of matrix AN over the determinant of matrix A. Okay. Then we then came to this example. Okay. From this system of equations, from what is on the left-hand side, we form this matrix A. Do you agree with me that matrix A is formed by what we are having on the left-hand side?
Yes.
Do you agree?
Yes.
Okay. Then from there, we replace the first column of matrix A, but what is on the right-hand side, to have this A1.
Correct.
Okay? Then next, we replace the second column by what is on the right-hand side to get A2. Okay?
Okay.
Finally, we replace the third column of A with what is on the right-hand side to get this A3. Okay?
Okay.
Then from there, we calculate the determinant for A, the determinant for A1, determinant for A2, and the determinant for A3.
Okay.
Is what we're busy with now. Now we are about to verify what they found. Okay.
Okay.
Lerato, you said Kia found 236, ne?
Thank you.
Okay,
Yes.
you're welcome. 236. Theo, what did you get, my brother?
152.
152.
Yes. 153.
Please talk to Kia.
Kia.
Oh, unfortunately, Kia is now. She has now changed. She's now using sign language.
Oh.
She's having a problem with the mic. So now, let's come here. Remember from this theorem, x1 is equal to the determinant of A1 over the det of A. Ne? X2 is equal to the determinant of matrix A2 over the det of A. Up to xn equals to the det of an over the det of A. So in this case, we'll go up to x3. Lerado, you said the determinant of A is
44.
44.
Good man.
Okay.
Good man.
Yes. You see, let's look at x1. The determinant of A is 44. And then Tando said the determinant of A1 is 40 or minus 4. Tando, did you say 40 or minus 40?
I said, yeah, negative 40.
Negative 40. Now our x1 is minus 40 over 44, which is the same as minus 10 over 11. Is x1 making sense?
Yes, it is.
Now we are moving to x2. A2 was calculated by Nomtandazo. Nomtandazo said the determinant of A2 is 72. We agree. Then we divide by the determinant of A found by Lerato. We get it to be 18 over 11. Even if you don't simplify in the exam, if you don't have time to simplify, it will be okay. Then x3, Theo found the determinant of A3 to be 152. Next time when we see Kia, then we need to find out how she found the 236. Because the determinant of A3 should be 152. Then we divide by 44. If you are able to simplify, please simplify. If you are unable to, it is okay the way it is. Then we are done. That's Cramer's theorem.
Sir.
Is Abdul here?
No.
Oh. That's it with Cramer's rule.
Sir.
Yes.
What do you use it for?
Good question.
Because it does not find determinant, does not find anything.
I don't want to lie. The application of this grammar, I don't want to lie. Now, that's all about grammar. Straightforward. If it is 10 marks, then please, no negotiations. Eh?
Yes.
Just like, please. Let's look at this theorem of equivalent statements. We saw this several times. This statement, we saw it several times. Let's look at this theorem. It says if A is a square matrix, then the following is invertible. Only if A is a, n by n means n is a square, A is a square matrix. Remember? Ax equals to 0. That's only the trivial solution. Remember, we talked about this? You forgot. Please go and remind yourself. Number C says the reduced row echelon form of A is an identity matrix. D, A can be expressed as a product of elementary matrices.
Yes.
AX equals to B is consistent for every n times 1 matrix B.
Yes.
Meaning number of rows, 1 column. F, AX equals to B has exactly one solution for every n by 1 matrix B. And the determinant of matrix A
Cannot
is
be.
not 0.
Yes.
Then, if you and I are happy, the next time when we meet, we'll start to talk about this exercise set.
Okay.
Is it okay?
It's fine.
Then, after that, after talking about this exercise set, then we'll immediately talk about that next section. That is it talking about vectors, ne?
It's vectors and then
Yes.
complex numbers done.
Then is vectors, then complex numbers, then we are done, then we'll start to revise. Any question?
So,
Yes.
like, I know that like exam period is nearby and that they are trying to cover as much ground. But like these workshops, when you make them, like, I'm not saying names, or I'm not saying you're gonna do it. There's some people that like do 3 in the same day. Like, for example, today from 9 to 12, 1 to 5, 2 to 5, there are a lot of workshops. So like when you make them, we understand that they're trying to cover ground. But like they should be spacious and accommodating, something like that.
Which ones? Or the ones that you saying are currently taking place?
It's like today, I'm not lying when you say I had a long day with Mark Wayne. From 9 to 12, 2 to 5. And there's this one, 5 to 7. And all of them equal. They're all the same importance. We can't skip in between.
I understand, brother.
So like space them a little. Like, and like, you understand what I'm trying to say?
Yes, yes, I do. I do. I do. Lerato? Lerato? Lerato?
Sorry.
My brother, this is still the beginning. There is a time where you are going to be writing in an exam. Ne? They will only tell you the starting time. Then you will be writing until you are finished. You will get to that stage.
Because I saw a miracle today. Literally 2 workshops at the same time. By the same, what's this thing? The thing that Mem Dikeledi does. It's the same person. I don't know what they are called. She both sessions, and she's attending both sessions at the same time. Even the recordings at the same time, everything. I was shocked. Like, what?
Which module are we talking about?
It's 1613 and also one.
Meds.
Yes, and also 1506. It was at the same time by the same person.
How so, Lerato?
Like, I don't know how they do these things. She's a miracle lawyer, that person. For sure, you know her. It's Marles.
Is she the lecturer?
No, she does the same job as you. The facilitator, there are different people, but she's the one recording, sharing the recordings, sharing the papers and everything. It's the same person.
It's the last kick of the dying horse, Lerato. Now we are trying to assist. as much as we can. We don't want Kanakwa exam or we didn't do anything to assist. We are trying to break away distance from long distance education, to bridge that gap. I understand.
Okay, no problem.
Yeah. Yeah, I get it. Now, if we don't bridge that gap, you are on your own, you are struggling. So they are trying to make your life easier. And some of these people, maybe like Obolela, or they are like us, maybe it's an external person, or maybe it's an agreement between the person and the lecturer. That's when they are available now to assist. I get some of these things, it's a collective. If I'm not available, Glenn won't be able to work. We coexist. We are trying to help. So Lebona, if now Mr. Makado and with Glenn, we don't sit down to assist, it will be a problem. So Baba Ira Nako Ebanaliona ki to assist, because they know the examination is around the corner. You might be sitting here and without you understanding some things. They are trying to bridge that gap.
Okay.
It's for your own good, though it's too much. Try to get to attend them as much as you can, though it's strenuous. But if you can check, we don't count September anymore. Next month it's exam.
Yes.
September is already. Next month is exam. And exam, I think it's starting earlier, the first week of October, some of those modules. So you understand we are on a tight schedule.
Okay, I understand. But like two at the same time,
Whatever it takes to pass, man. Whatever it takes to finish the module.
Yeah, you know.
Okay.
I'm not shocked. I won't lie. I'm not shocked. Hey, dude.
It's too much.
I'm not shocked.
Jackal.
Yeah. Again, the funny thing about it is, it will only get worse from here.
It gets worse.
Dude, we're still first level. What do you think happens when you're doing honors, masters? It feels like you're drinking from a fire hose.
That's why there will be a time exam. It will be in a starting time, but not end time.
Yeah.
Yes.
So in a way, we need to learn to deal with the pressure and its complexities now. Because the higher you go in level, the less hand holding there is.
It's hot up there, Levant. It's very hot up there.
One of those situations where you've got an exam now, then you've got another one later. Sometimes the exams are clashing. They're teaching us. Yeah, they're teaching us that the higher you go, the higher the pressure is going to be. So it's also pressure management, where we learn now to manage our time. We learn how to do more than one thing at the same time, where we interleave information.
Okay.
But it's for your own good. Remember back on UJ, they are getting what you are getting every day. So if they are giving it now towards the end of exam, towards examination, just grab it.
Okay.
Grab it. Or if you didn't, try to listen to our recording. That's why we record some of this session. That's why we post some of this session, so that you can go back and refer.
Okay.
Ke nyaka bona ka email e o romelang ka yona le rata o sharela le Dlele le Mr. Makado re botse re passitse. That's why that's why we don't mind sitting here. We want to see those results. We want those results, Baba.
I don't mind at all.
Yeah, that's why we are sitting here at this time. As long as you are fine, as long as you are understanding what we are saying, that's all for us. That's enough for us.
We can sit until tomorrow morning. We have got a chef. Who is Tando? No.
Oh yeah, Tando's the one with the food. Oh,
yes.
Artolele Tando.
Yes. We know. Tando bring the food.
Yes, I just remember the Tando's the one with the food here.
Yeah.
Come, let's dine. I'm eating.
Maybe Theo is leaving. It's not even here with us. Theo, are you around?
Yes, I'm still around.
Oh, okay.
I'm gonna come for dinner and corner.
Okay.
But I'm gonna invite you when you've got electricity. That's when
Hey, wait.
Me, I don't want to eat by literal candlelight.
Yeah, no. Spoonuk
yes.
If there is no question from Anybody? Then let's agree that we will meet on 1/5 to the following week.
Yes.
Yeah.
Oh, Nick. Oh, Monday is calculus.
Yes.
Yes.
The beautiful
Then,
beast herself.
On that one, we need to. I don't want to say we need to move with speed,
but we need
to move, but making sure that we understand, because I think is the one that you are studying the exam with before this one.
Oh, really?
No.
Yeah.
I think remember it was one that was going to be late. This was the 1503 is the one that was supposed to be early. But now I've sent an email to exam today just to request those as exam dates. As soon as I get my facts straight, I will share them with you.
Oh.
I will send you emails,
Okay.
guys.
All right, okay. Lady, thank you so much.
All right.
I'm just saying this because I remember we haven't yet started integration. Ne?
Oh, yeah.
We are still differentiating.
Hey, and we need to integrate, because integrating is not anyway. It's integrated into the exam.
We need to integrate and then go calculate that population of the bacteria at the end.
Oh, yeah. It's exponential growth and decay.
Yes. So we still have got a lot to cover.
Okay.
Okay. On that note, please enjoy.
He is asking something. Somebody's asking something.
Yes. Quick question. So, the question. So, I'm assuming if all goes according to plan, we're going to cover the syllabus basically. Then we're going to, if God willingly, we'll also do questions like from the exam paper, right? Past papers.
On this module, I'm quite sure that, because I think after the exam dates have been confirmed, if there are still the way I've seen them, then I'm quite sure that we'll have much time, but let's wait for the confirmation.
All right.
For those days.
If we can get to the point where we even do question papers, I'm telling you, distinction.
Yeah, we will.
All right. Thank you, family.